Hello, am I audible?
Yes, sir.
Okay, so let us start. So today we will solve some questions based on registers and also some questions based on ROM and behavior modeling in Verilog. So, uh, let us start. So the question says that a ROM is used to implement the Boolean functions given below. These are the four functions that a ROM has to implement. The number of address. Okay, then we have to answer some questions. So first, we have to see how functions can be expressed in ROM, right? So we had seen this in week 5 videos also. So this questions is kind of a revision for that. So what you could do is like you can make a truth table and F1, F2, F3, and F4. So okay, so this A, B, C, D, these four lines behave like address lines, and this is kind of our data. So first we have to find out what will be the values here based on these functions. So try it out once, then we'll see this. Try to fill the truth table.
Sir,
Yeah. Yes. Yeah. F1 is correct. 0, 1, 2, 9, 11. I have to write it. Let me write. F2 you can also write directly. 0. What will be F3 and F4? F3. Please go for F4. Okay, so now the question says the number of address locations having data 0, 0, 1, 0, 1. So we have 0, 0, 0, 1 here, 2, 3, 4, 5, and 6. Right? So answer to this is 6. Why are you saying 4, Nishan? Okay. Next one is number of address locations having data 0, 0, 0, 0. So how many zeros? 4 zeros. We have only
One.
this one. Yeah. Only one. Next is having 0, 1, 1, 1. So do we have any 0, 1, 1, 1? We have one here and one here, right? So answer to this is 2. Next is what is stored at address 10. 10 is this one, 0, 0, 0, 1. What is stored at address 2? Address 2 is this. It is 1101. And the last question is which of the following statements are true for the above round? The total memory required is 16 cross 4 bits. Total address bits are 8. Total address bits are 4. Memory required is 8 cross 8 or none of the above.
1 and 3.
Right. So we had 16 rows of data of 4 bits each. So it is 16 cross 4. And to access 16 rows, we need 4 address lines, which were A, B, C, and D. This was simple. So next question is we are designing a memory system. Answer the following questions. How many address lines will be there for a 128 KB memory, which is byte addressable? Okay, so first we should know what is byte addressable.
8 bits. Will it be k equal to 7, sir?
What? K equal to 7? Did you say K equal to 7?
Yes, sir. Yes, sir.
Okay, so what is K?
So you write 128 kilobytes is equal to 2 power k into number of into word size,
Okay, right.
and then you get 128 kb equal to 2 power k. That byte and byte will get cancelled, so we get k equal to 7.
You're missing, okay, 128 KB. We have total size. We have each address has one byte word, right? So total address is 128K, not 128. Okay, so 2 to the power K equals to 128K. 128, or I should write, we can write it 128 into 1024 maybe. So this is 7. Okay, so K equals to log 2, 128 to 4. K equals to 7 plus 10, 17. Is clear? So memory size is 128 kilobytes. So if each word is of 1 byte, then you have 128,000 addresses, not 128 addresses.
Okay, sir.
Okay. So you will need 17 address lines. Okay. So next one. So this is simple. 128 KB memory is hierarchically designed using 68 KB memories. How many 16 KB memories are will be required? So
8
yeah, simple, just 128 KB,
divided by.
16 KB. This is 8. Next one. So this is little more interesting, building on the previous question. 128 KB memory is hierarchically designed using 16 KB memories. If input to 128 KB memory is this address line, 16 is to 0, that is 17 address lines. What is the address to 16 KB memory? Okay, so yeah, these correct. So basically, how we can understand it, like 17 address lines are required for 128 KB, and which is made of 8 of 16 KB memories. So let's say we have 8 memories: 1, 3, 4, 5, 6, 7, and 8. So to address these 8, we just need 3 bits, right? 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1. To identify these 8, we need 3 bits. The rest 14 bits will be used to internally address each memory. So out of 17, if we are using 3 for identifying 16 KB, identifying 1 out of 8 16 KB memory, there's 14 lines to address each 16 KB memory. So 14 less 14 lines are what? So the option is correct. Okay. So next one is okay. 128 KB memory has a 2D layout. Which of the following decoders are most suitable for the memory? What? Radius of what, sorry? Okay. Yeah. Okay. So, can you tell me just like location somewhere? Sure. Thank you. Okay, so let us look at it. So basically, you have to like extract information of this question, right? So 128 KB memory has a 2D layout. So in 2D layout, generally what we have is it is like byte and decimal. So it's again 128 KB, and there are 128K address lines, sorry, addresses, and 1 byte word. Now for 128K addresses, we have already seen we need 17 address lines. We have calculated. So decoder inputs, we need at least 17 decoder inputs and 128K decoder outputs, right? So ideal decoder would be 17 cross 128K decoder, but we do not have that. So we can have a combination of that. We can break it down. So out of these, this one is correct. So we have 8 and 9 adds up to 17, and 256 cross 512 adds to 128K. So this will not work. We have 5 cross 32, 2 of 5 cross 32, 2 of 8 cross 256 will also not work. This will work. This can also work, but it is like uh, having it has extra, it's like having extra uh, address lines. So the most suitable one is this. Is it fine?
Yes, sir, fine.
Okay. So this question is very log related. So let me know what you get. So I'll be back in 2 minutes. Okay, so do we have an answer?
1 and 3 are correct.
Okay, so actually all three are correct. So assignment is reevaluated every time any term on the right hand side changes. So what it means is like maybe assign z equals to maybe x and y. So either if x changes, y changes, z will be recalculated. So this is what it means and which is correct. Third one means that it must describe some combinational logic. Yeah. So with assign you have to either give some combinational logic. And this is also correct. Always blocks are reevaluated only when signals in the header change. So in general, what we read is like always blocks, like they are always uh, what to say? They are always reevaluated. So what does it mean? Like signals in the header change. So maybe so if you take, let's say this is your header, right? So if any of these changes, your always block will be whatever is in the always block will be reevaluated, which is actually correct. So basically, you are giving it, if anything changes, any of the inputs that you have marked or any of the outputs, any register that you have marked as changes, your always block will be re-evaluated. That is why it is called always block. So this statement is also correct. Is it clear?
Yes, sir. Clear, sir.
Okay. So, okay. This you can answer. The below Verilog code works as a
3x8 decoder.
yes. Into the 3x8 decoder. Basically, you are mapping 0002 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, 1, 0, 3, 4, 5, 6, 7, This is just like a decoder. Okay, so we have few more questions which are based on registers, which are also very easy. So you have this is a serial input, serial output register. So in this CISO register, you have already stored something which is 1011, and the next inputs to be processed are 101111. The question is, after the second clock cycle, what is in the registers? Okay, so we have seen this is a serial input, serial output register. So whatever you feed in every clock cycle, it will go to the next one and finally come out. So next input will keep on going. So initially, if we have, let's say, 1011, and we have in line 111011 to be fed serially. So in the first clock cycle, what it will be? This one will come out. This will go here, and this one will come here. Now you have 11101 to be given as input. In the second, this will come out, 1110, and remaining input is 1101. So in the second clock cycle, you have 1101. Let us make it for the whole thing. Third, fourth, fifth, sixth. Okay. In the third cycle, this will go out. This will come here, here, here. This one will come here. 1111. And remaining input is 101. In the fourth cycle, this one will come out. This will come here. Let me take another color. 111. This one will come here. 1. Remaining inputs are 0 and 1. In the fifth cycle, this one will go out. 111. In the sixth one, it will be 1101. Is this clear how a shift register is working? You just have to shift right by one place at each clock cycle. So this is serial input, serial output register. Is this clear how this is working?
Yes, sir. Clear, sir.
Pretty, yeah, it's pretty straightforward. So in the second clock cycle, your output is, oh sorry, the digits stored in your registers are 1110. Next is in fourth cycle. In fourth cycle, what do we have? We have 1111. Fourth cycle is 1111. Next question is fifth cycle. It is 0111. And the last question is sixth clock cycle. If this was 0111, it will be 10. This is the answer 1011. Let's check this. 1011. Okay, so all these are all the questions I had for today. So Nishan, do you know why only you have joined today? Is there some exam or
Sir?
something?
No, sir. There's no exam.
Okay. Okay, so if you have any doubts, any other doubts you can ask, else I do not have any more questions.
Sir,
Yeah.
in the assignment, there was a question, so number of clock cycles required to store and retrieve data from shift register.
In this time assignment, this week.
I'll, yes, sir, I'll copy the question, so 1 minute. This question, sir.
Number of clocks required to store and retrieve the data from an n-bit shift register, given n-bit input data. Okay. So what do you think is the answer?
A or D, sir? I don't know exactly which one.
Okay, so let us see. Just a minute. Yeah. So we have four registers. Let us take a 4-bit register example. Okay, first is serial CISO, serial input and serial output. Second is SIPO, serial input, parallel output. Third is PISO, parallel input, serial output. Fourth is PIPO, parallel input and parallel output. Let's say you have the data 1001. You have to load and retrieve. So 1001, if you have to put in this, in first cycle, this one will go here, second cycle here, third here, fourth here. In 4 cycles, you will have 1001. Now, to get it out, like in the next cycle, this will come out. Like basically, you need approx 2n proportional cycles to feed the data and then take it out. So once you have fed in 4 cycles, if you have fed 1001, then you need almost 4 more cycles to take this one out, then take this zero out, then take this zero out, then take this one out, right? Okay. So the number of cycles is proportional to the 2n in this for load plus retrieve. For serial input, parallel output, you just need, if you have to load, you just need 4 cycles to load it. Retrieve can be like, since all of these locations are accessible, you can retrieve it all at once. Okay, so they have written like 2n minus 1. Why they are writing minus 1? So the logic behind this can be, uh, so let's say you have something which is reading the serial output from here. So what it is reading? It is reading this last memory block. So once you have written 0, 1 here, this is being by default read. It already knows what is here. So it needs 3 more cycles to transfer this 0 here, then this 0 here, then this 1 here. So after load, 4 cycles for load, you need 3 cycles to put the data, all these 3 data values here. That's why it is 2n minus 1. That means your whatever system you have is able to read the last from the last bank. Similarly, what happens in parallel? Once you have fed your whatever you have a comparator, what it is able to access all 4 of them together. So for reading or for retrieving, there are 0 cycles required once the data is fed because it is simultaneously it can access all the 4 values. You do not need any additional clock cycle for that. So for SIPO, it will be, if we have, it will be N. PISO, parallel input, so 1 cycle for loading and 3 cycles for output. It will also be approximately N. PIPO, it will be just 1 cycle for loading, 0 cycles for output. Once you have load, you are reading all 4 together. So it will be 1. So answer can be 2n minus 1 and n 1. So option B according to me.
Okay, sir.
Is it clear what I was trying to say?
Yes, sir, I understood.
Anything else?
So, but what is there in the videos are not enough to solve those questions.
Uh, yeah, that may be true, but okay, like that happens in any exam you give. In your college exam, does is everything uh, exactly what you are taught?
No, sir.
Yeah. So expect the same in exams also. So this you have to be like careful. So in videos, what you have, I think maybe 2 hours of uh, knowledge, whatever professor is speaking, right? In
Yes, sir.
1 week video, and that also you can watch in 2x and finish. So these videos are just for your like reference, what is there in the course. Then around that you have to explore more. Everything is not being taught, that is true. But overall you have an idea what else is there. So the assignments are there to like broaden your perspective, like what kind of questions you can see, what could be asked, what are the further subtopics. So like I would suggest maybe follow some book, like if you seriously want to learn the subject, just not just pass the exam. So follow some standard book along with the course parallelly, so that if you're covering the chapters there, then you're covering everything.
Sir, will we get previous year question paper?
That I am not sure. Uh, I think at the end of the course there will be a session by some other TA, some other I don't know instructor from the NPTEL, which like tell you what kind of questions do come or clear your doubts regarding exam.
Okay, sir.
So I do not think they give explicitly what like previous year papers, because it is again online exam, so nobody remembers what. So people cannot share exactly what questions came. But from my experience, from what exams I have given, it is mostly related to assignment, but again, not limited to assignment. There will be some questions from here and there, but a lot of them will be from your assignment. So maybe practice
Oh,
previous year assignments also. That will be helpful, and this practice non-graded assignments and the graded
the,
assignments.
these are previous year questions, sir.
Whatever I am teaching is previous year as last year's assignment.
Okay,
This year's
sir.
assignment is quite different, which you are solving already. So I
Yes,
think
sir.
this is, or we are solving almost like 30 to 40 questions each week. So this is, I think, very much sufficient to uh, cover a lot of topics. And if there is something else, it will be like very few questions will be outside from these assignments.
Okay, sir.
So Nishant, you are in BTech.
Yes, sir. BTech. No, sir. B.
Okay, which year?
Fourth year.
Which college?
Nitte Meenakshi Institute of Technology, Bangalore.
Okay, Bangalore. Great. So, okay, so you are looking for job after BTech, or like you want to do higher studies?
Yes, sir. I'm on to looking for job, but this NPTEL course is part of our syllabus, sir.
Okay,
So we need to write this exam and then submit the certificate. Then only they give the certificate for degree certificate.
okay, okay, great. Okay then, uh, I'll see you next week.
Okay, sir. Thank you, sir.
See you.